1, 2, starting 1, 2. Okay, welcome again everyone to another episode of Dan Does Data. Tonight we are continuing to look at our self-driving car model, and I wanted to look at just the steering. I want to focus on this aspect of it. Previously we had fought with our model to try to get it to actually output some different values, and I fought with that enough. I got that to work. The key turned out to be switching the activation function from sigmoid, which I suspect I had a vanishing gradient problem, to where my activations were always really small, and so the gradient was never changing, so I was never getting different outputs, essentially getting a lot of zeros, to this ELU, this exponential linear unit, which in fact I believe is what one of the self-driving car models that I looked at uses. So this is built into Keras. This is nice, and you can use it in your functional model in Keras, not a sequential model. You can use it in sequential too. There, it's pretty trivial. You essentially have to just create an ELU object and then pass your layer into it. So if you're looking at like right here, something like that. That's how you can do that. Once I did that, I got some different outputs. They weren't necessarily good outputs because again, we're not training that much, but it did something, and that was just the goal. And I think I did not get around to adding regularization. I really should. That's a problem for another day. I'll worry about overfitting when my model starts doing well. Before then, I'm not going to worry about it. That seems like a reasonable thing to me, huh? So what have I done so far here? I did a little pre-planning stuff. All I did was take out the acceleration component. So I just took out those layers and I took out that output. And so we're just focusing on the steering. And maybe I can have it do a little bit better if we just do that. And so I trained it up already now. And let's take a look at what the output looks like here. What is H? H.shape. So I did the prediction. Yeah, there we go. And if you do this, next one is out of bounds. I should have known. What is P in this case? P is not defined. Right. So I did all the predictions. I just want to see what they look like. P. P.shape. Yeah. P of 0. Oh, P of 0 is 0. Oh. So if I took that. Well, now it's outputting all zeros. That's no good. In fact, yeah. So this model is once again, tragically, outputting all zeros. It's starting to irritate me that that is the only thing my models are capable of doing, outputting all 0. Like, that's not even a good result. Like, all 0.5. That would make sense. I could get behind that. I would support that, because if you take a look at the model itself, where is it? I was taking a look at the values. So these are the steering values, or what I'm pretty sure are the steering values. There we go. So it's very heavily centered around 0.5 because, you know, you're pretty much just going straight. So that makes sense. This is swapping what in the documentation were labeled the steering and the accelerator. And we can look at the accelerator in a second too. So I'm pretty sure this is the steering. You go, I think this is right, this direction, and this is left. And it makes sense that you turn one way, you turn back the other way pretty soon, if you're going around a curve, for example. But for whatever the 1,000 frames that this particular one represents, usually you're going straight, you're nudging a little bit one way or the other. This wouldn't make sense in a accelerator situation, right? Because this would mean that you're not accelerating, you're not hitting the gas at all, hardly. Except you're tapping a little bit, you're braking a little bit, tapping a little bit, braking a little bit, tap a little bit, brake a little bit. I mean, that's really annoying. Then you suddenly accelerate and you suddenly decelerate. Or you suddenly decelerate and you suddenly accelerate. So I'm pretty sure this is the steering. But it should be about 0.5. Like, if you just said your model was 0.5, I mean, you wouldn't do that bad. You know, you'd be doing okay. So why is this model broken now? This is irritating me. What does W look like? Is it lots of zeros? No, W is... Well, Well, they're smallish values. They're not zeros, though. It's probably that final sigmoid output. If I just happen to have a lot of negative values coming into the final output layer, that might be all it takes to make it all 0. Those are some tiny, tiny weights there. Oh my goodness. Oh, no, okay. Oh, there is a non-zero value. Oh, so this is some Python numerical precision error, I bet. They still shouldn't be that small, but that might be what we're hitting. It might be that we have bad input, and so it's not able to learn sufficiently. I tell you what, let's do something crazy. Rather than a sigmoid output here, let's do linear in our final layer. So in theory, you could predict values less than 0 and greater than 1. I'm willing to accept that for the time being, is what I'm deciding. So let's recompute. And you'll notice my metrics have changed from accuracy, which doesn't make any sense when you're trying to predict a real value, to just mean squared error, MSE. That's all that is. So I mean, it's going to equal the loss. Let's try this. And once it's outputting some different values, and if it's not, I'm going to go back to the other model, and we'll fiddle with that. Because that was definitely outputting some different values, reasonable, not crazy values. So yes, we're switching to a linear activation because I'm worried the final sigmoid might be weirdly squashing things. But if I do linear, hopefully I'll see some real information. And if I see some like wildly negative values, that'll give me some clue as to what's going wrong. I guess I could also output some other things. So the loss is going down. That's good. The loss is now really small. Wow, that's really crazy. I mean, this is the mean squared error on 1,000 entries. That is eerily small. Maybe when you do sigmoid activation, the output gets weird because it's expecting it to be I don't know. The sigmoid maybe is not the right kind of output for just predicting a value between 0 and 1. Oh, you know what? Let's ask the internet what the appropriate thing to do is. I mean, really, it is a regression problem, but you've got censored values or your clamped values. So what if I say Keras clamped regression? No, clamping the weight vector, no. Restricted regression. Restricted Boltzmann machine. Oh, that's not why we're doing that. Okay. Restricted least squares. I just saw that for a second. Here we go. Set a priori restrictions on the elements of vector beta. That's not what I need. I don't need restrictions on the regression coefficients. I need restrictions on the outputs. Wow. That's terribly interesting. This loss is pretty impressive. Okay, and the loss is changing, whereas for whatever reason the previous model it was never changing. So 10 epochs may be too much even, given that it takes 4 seconds per epoch, so that's 40 seconds per model. There's 11 models, so you're looking at 440 seconds. Or like 7 to 8 minutes to train this thing. So I don't want to wait that long. I'll make this 5. And I'm probably going to interrupt this once it saves some output here. Yeah, there we go. Ding. Okay, that's fine. I have a much better feeling about this now. We just go ahead and do this. Where's Allpred? Do I not create that up here? Oh, interesting. Very interesting. Okay, so we'll create an empty all prediction list. There we go. And this shouldn't take very long. And we'll in fact we'll be computing values for data we never saw. because it doesn't take nearly as long to compute all these values as it does to spit them out. Also, it's good to see that I can make a lot of predictions. That I can make 1,000 predictions in less than a second. That bodes well. I don't know what the frame rate of the webcam we're actually going to have for this self-driving car is, but I don't think it's 1,000 frames a second. If it's like 30, that's probably good. Honestly, if it's 10, that's probably fine. There's a limit to how fast our mechanical controls can actually react to. So that's fine. That's not going to be a limiting factor. I was worried that I was going to take whatever model I built in Keras and implement it in something more low level. Maybe directly in Theano, that wouldn't be bad. Maybe directly in CUDA or something. All right, this should be done momentarily. I appreciate everyone waiting. As always, feel free to shout out questions from the audience about why you think, what's going wrong in this model, what kind of thing you might want me to focus on next in this model, or just in general. Like I said, this week I want to focus a little bit on the steering. Maybe next week we'll focus on the throttle. I'm going to change the throttle model from trying to predict a value between 0 and 1 to just predicting, are you stopping or are you going forward? That's sort of the plan. That's interesting. That's not really what those shouldn't be different colors. I'm not sure what's going on. What? Oh, those are different colors because there's 11 of them. Right. All right, that is wrong then. Yes, that is most definitely wrong. It's better, but this is just like giving me an average value. Okay, this is giving me an average for each guy. Right? So this is all about 0.5. And this one, it says, oh, the average is this. This one says the average is that. That's wrong, 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 though. I don't know why it would do that. And why is P 0 here? Doesn't make any sense. Let me just look at all red. Oh, no. These aren't all. Oh, they're just all so close within a range. Oh gosh, what did I do? That's interesting. So those are not all the same values. I mean, there's a handful of values that... This is interesting. Like, those look like legitimate values, right? If I look at the first set, and I plot that, this should be... Yeah. I mean, it's never like hard turning all the way to right and hard turning all the way to left, but that's fine. I don't have any problem about that. I prefer dots in this case. So it's predicting properly. I think it's just, this isn't even within a narrow band. What if I plot that plot? I'll just do this. What happens? No, it doesn't like that. Does not like that at all. P equals all pred 0. Oh, I see what I screwed something up here. I see what I screwed up. Just in how I plotted is what I did, because I didn't have multiple entries in my all predictions array before. Index 1 is out of bounds for array of size 1. What? P of 0. Alright, fine. Why is that I? For I in range. I guess just that. There we go. So I was always looking at like the first value or something. So this is an entirely reasonable looking graph. And the model is not crazy stupid. My plotting, turns out, is just kind of dumb. So what are some quick problems you notice? This graph goes above 1.0. There are a few times when the model thinks, hey, let's turn as hard as more than we possibly can to the right. And likewise, there's going to negative 0.2. It wants to turn more than it possibly can to the left. But, I don't know, it's not the end of the world here. Again, the model is predicting things that cannot happen. In the real world, however, we can just set threshold that at our max. And that's going to futz with our statistics. But you might notice these aren't necessarily like super normally distributed values to begin with. Well, the predictions aren't. The inputs aren't either. Actually, what we should do... Let's take a look at our predictions versus... Predictions versus... no, not predictions and actual. There we go. We could do verse, I guess. That's even easier. No, let me throw in accidentally a word. Perfect. Plot. Which one is interesting? Plot. Alpred of 3? Is that the one? Oh, that one's got some interesting things going on. What about 4? It's one of the later ones. No, 4's no good. Oh, wait, what? 4 goes way down. Oh, maybe 4 is interesting. Okay, 4 is interesting. Too late, I decided. All pred 4, comma, targets. I gotta read that file. Right. I tell you what is targets right now? Ugh, targets. Yeah, targets is whatever the last one is. So what is plot.plot of the last guy look like? Alright, that's sufficiently interesting for my purposes, so I don't have to read in targets again. -1, there we go. And targets throttle and steering scale. Hang on. Yes, those are being scaled that way. I gotta look up which one is the right target to use. Target 0, okay. 0, there we go. I forgot to click the button on Reddit again. Every time, almost every time. Should I build a machine learning model to see how often I forget to click Reddit and say, hey, you can come see me from Reddit. Okay, plot.plot. Let's take a look at that. How we doing? That's a lot of things to plot there. Should not take this much effort. Oh, no, it's not. I missed one of those. There we go. That didn't work. Cannot broadcast array input, 1000 shape. Targets, :0. Shape. No, that's fine. So allpred is the problem. Allpred, -1 dot shape. So let's just reshape that. Reshape into 1000. That should be fine. That's no. Why you doing that to me, pal? Why are you doing that to me? First of all, I wanted to just plot x versus y. Oh, I shouldn't pass them as a single. They should be multiple arguments. That's what it is. Right? Because if you look at plot.plot, it tells you xy. If you just plot y, that's when you get this thing. So I might be able to restructure this other plot to take advantage of that. But we'll get to that when we get to that. Okay. So in our ideal world, we're on a line from 0 going through. Let me square this up a little bit. Well, that ain't gonna happen. That's approximately square. I'm sure you can tell it's a plot square. We'd be on a nice line of 1 to 1. You see that that's not really happening here. There's some vague positive correlation. There's something here. There's a whole lot. We just predict 0.5 a lot. And the value is actually 0.5 quite a bit. And those numbers don't necessarily line up. Okay, I actually want to plot just 2 sequences. I want to plot, let me see, So I want to plot together all the guys that we got. If I say numpy.array u and then dot transpose, does that do what I want? There we go, that does what I want. And I think I didn't label this. I think the green is the actual, right? Because it's much more uniform. You see, stretched around. That might be a little small. Let me make a bigger thing for you guys. There we go. A little bit bigger. A little more clear what's going on. So the green is the actual, and the blue is the predicted. And you see the blue is, well, kind of all over the place. It's predicting a lot of driving over to the left here, or right, whichever way that is. Over here, yeah, it's a little more all over the place. Whereas the green, very stable right there. But of course, the model didn't see any of this data because I killed the training before it got a chance to do that. Okay, so this is interesting. We didn't expect the model to do good on this because it has almost no training, and it didn't even get to see this. What if we look at just the first file, say? We reset all red. So that shouldn't take long at all. There we go. It gives us a variety of values. And then let's plot our prediction now. Well, so this wasn't a very interesting file. Wasn't a very interesting drive. It was mostly 0. Or mostly just going straight. But again, our model is predicting, you know, a lot of numbers in the general range of listing to the left, I guess. Just happens to be what it's seeing right now. Interesting. And where the model starts to go bonkers, or where the actual values are way up here, it's not seeing too much. Oh, you know what? Let's do something. I want to put that as x's. Say blue x's for the. How can I dictate the color array? Or the. The character array. Alright, whatever. So that was interesting. So here's what I want to do. I want to try to set up a visualization for the model, and while I do that, I want the model to train. So I'm going to say, take 10 epochs, sure, and go to town. There we go. So I don't need this. These are old comments. Set up visualization. And I still haven't installed GIMP on this machine. I meant to do that, so I could do some cool drawings for you guys. Oh well. That will have to wait for another time. So what I wish to do with this visualization is, I don't think they have it in deep drive. I want to draw a picture on the image, just pointing in the direction of where we want to steer. And eventually, when we get the throttle situation worked out, it will be like the appropriate length of however long that is. Really, it's going to be on or off, so that doesn't really matter, I guess. Excuse me. So that's all I want to do. I've seen this on another model. This was the AI, not AI World. It's the model that people linked to me several times before. Ah, man. Comma AI, yes, there we go. Nearly forgot. Yes, and they have a separate steering model and generative model. I think this might be only a steering model. Yeah, so they're drawing something like this. So I think that's the direction of their steering, and that's the idea of you're going to end up over there where this blue is. And they have some videos and information on that. Oh, the steering model. This just tells you how to do it, but it doesn't tell you what it's doing. And I think we're probably not going to do it the exact same way that they do it. I think they're using Ubuntu as well. Maybe not. Train steering model. No, view steering model. That's what we want to check out. They are doing this with Pygame, which I haven't used Pygame before, so I'm not going to try to learn Pygame for the purposes of this. But I have seen other things like image GIF, I think. Python image GIF. Let me search this on the new tab. There we go. Tkinter photo image class. Python make GIF. GIF, whatever you like to do. Program to generate video of animated GIF in Python. Oh, you can do it in scikit image. Maybe that's what I want. So OpenCV is Open Computer Vision. If you have no idea what you're doing, but your boss told you, I need to do image recognition, just take a look at OpenCV. At some point, I will probably do a video on it, but it's just like a nice GUI for you to like poke around and see what you can do. And my understanding is it's not as heavy on the math or even programming. 7 images you want to create a video from. Oh, honestly, if I just had a set of images already, I would just use convert or like image magic. Images to gif.py. Formerly images to gif.py. Update courtesy of such and such. To reverse the images, yada yada yada. Look, I'd rather have a proper pip. That's with OpenCV. Cool. Import CV2, okay, I don't need to make a GIF. Here's what I need though. So this will happen when we're actually reading in our data, but just for the sake of futzing around, I'm not going to worry about it. That lost, look at that. It's actually gotten worse? No, better. Always better. Better every time. What is with this weird base 64 stuff? Okay. So yes, anyway, this is sort of the kind of thing that I want to have. Let me go back just to show. This green line here is basically what I want to have. There's this spaced out, I assume based on some time step, like in the next frame you're going to be here, next frame you're going to be there, so on and so forth. I just want a line in base that general shape. So what we need to do is, given our all preds, those are our predictions. If I say all preds 0, those are my predictions for the first data set. And this is a steering angle. 1.0 means you're turning right, 0 means you're turning left. So I want to craft an angle from that steering angle, from that image, and I want to evenly divide this 180 degrees of space, or pi radians of space, into an angle that I can then actually use. And so 0.5 needs to be like the pi over 2 situation. So if I took sine of this value, that seems like I'm doing something wrong. I'm going to assume they already represent a uniform distribution, that yanking over that much 1.0 is like twice as much to the right as so 0.75, rephrase that, it would be like a 45-degree turn as far as the model understands. I guess that's not exactly true. That's not really going to be true, because your car can't turn 90 degrees in an instant. Your wheels don't go that far. There is some limitation on how far your car can actually turn, and I guess it would just scale to that, is the idea. And the more I think about this, I don't really need to compute an angle. The dumb thing to do, since I'm not worried about a magnitude, You set the first point of your line at the bottom center. You come up however far into your image that you care to draw your line, and you just number the pixels. And you know if you're 0, you're over here. And then 1, 2, 3, 4, and then 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. And you just draw a line between those points. However you're drawing a line in Python, that is. So the real question is, how do I draw a line on my image, and can I do that in SciPy? So Python add line to image. I don't want to add line, I want to draw a line. Draw a line, image. I don't need any prepositions or anything. Drawing a line in the image with PIL, image draw module, PIL. I've done this. Draw a rectangle. I don't want to draw a rectangle, but I do want to draw a line. Stack Overflow, work from home. Draw.draw. Draw.line from this location to this location with fill. I assume that's gray then, 128. How can I show the image? Before drawing the line, I could do this, but image show draw does not show the image. So I just draw that line. Wow. And then I need to. So I just want to save off what these lines are, I guess, first. So my images proper are size 64 by 64. So what I want to do, I'll leave a note to myself, draw a line from bottom middle to x, comma y. Y is fixed, and x varies with steering. That's all we're really doing, right? So I could say, let me define a stupid function. Get line. And the only input is my steering value. Steering value and my offset, start, end. Let's say start equals 0, end equals 63, excuse me. End equals 63, and the height equals, I don't know, 48. 3/4 of the way through the image. And so I need to divide up this S into one of 64 possible values, is essentially what I need to do. So the easy thing to do is to say int of S times 64, because S is a value between 0 and 1, remember? Int of that will give us some number between 0 and 63, essentially. If we actually hit 64, you know, good for us. Let's say pixel, x equals this. Then I say if x less than 0, x equals 0, we're thresholding, right? If x greater than 1, no, if x greater than 63, x equals 63. And by 63 and 64, so this should be end minus start. Right? If x less than start, x equals start. I think that's right. Greater than end, there we go. And our point that we're going to is going to be x comma y. So x comma height is all. Question from the audience. You reckon you'll need to do some sort of exponential or MA smoothing to see what it's really predicting? You can probably think about doing something like that. Like I could smooth over time, for example. The problem is I need to be able to predict this instantaneously. And maybe I can only control my vehicle to a certain amount, but I need whatever the instantaneous prediction is to be pretty close to what I want to do. Okay, so now we have a stupid get line. This is really get point, I guess. Get the point. Aha. If I say lines equals 4p in all preds, and that's a list of things. And then I can list map get point p. Get point, comma, p. No, I always screw that up. Yes, there we go. Let's see if this works. Oh, perfect timing, man. That was ace. I took exactly as long as I needed to come up with a visualization solution as far as getting the actual points. Name all preds not defined. All pred? All pred. Rookie mistake lines. These values are all over the place, that's fine, okay. And then, let's import PIL. How do we do this here? From PIL, import this stuff, okay. If I can get this to work on just one guy, that's probably fine. Okay, let's try that. That's not exactly what I want, but I tell you what, let's just see if this works. Okay, so this is just drawing any line onto an image that's all green. But I want to draw from not 0, 0, 32, 0, all the way over to L of 0, L of 1. And this is for L in lines, right? For capital L, and then for little l and capital L, right? Because I've got all these sets of data. This is going to be a mess, but just to show you that we're plotting all kinds of different things. Image show, things are getting inverted a little bit. So I need to be at the bottom, not the top. I see. I might need to fiddle with that. How do I read in the image properly using this? Using PIL is the question. Oof. Image.load? No. Image.open? Yeah, there we go. If I feed it a file, opens identified, give me an image file. Although, how am I storing this? I'm storing this as red, green, blue, right? Yeah. So my image is 0. What if I say, what do I do this? Can you do the right thing? Missing one required. Argument size. Okay, Python PIL. Oh, that's actually going to be useful. Python PIL load image data. Let's see if I can do this. And if I can just get this working, the image module EFF bot. That's not really what I wanted to do. Well, I don't understand why EFF bot is hosting this information, but whatever. That's for opening it once a file. Mode, size, color, file, blend, composite, from buffer. Hang on, maybe that's what I want. Image.from buffer. Image. There we go. RGBX. Modes. I don't understand why I have to pass in the size when it's from buffer, frankly. Modes. From buffer, from string, merge methods, load NumPy. PIL and NumPy. PIL image to array. Well, I want to go the other way. PIL image and NumPy array. How to convert between NumPy array and image. Let's take a look at this. Pick.getData. I want to go the other way though. Oh, here we go. How to load it back. Where of the put data method? You're not saying exactly how put data is not behaving. I'm assuming you're doing pick.putData. Load it back to the PIL object. Expects a sequence of tuples and you're giving a NumPy array. Well, that's irritating. The proper way to convert between images and NumPy is simply pix equals NumPy.array pick. Image.fromArray. Okay, that's the magic words that I needed. Image.fromArray. Image.fromArray. Ho-ho. Image is 0. Let's see if that works. Cannot handle this type. What? Why not? Image is 0 is it's a float. So if I say numpy.array of that, I say dtype equals numpy.uint8. Suppose I pass that into image.fromArray. Taking bets? Place your bets now? Okay. Alright, that didn't work either. Alright, how's that supposed to work? Image.fromArray. I guess EFFbot is where that's just hosted. Okay. Ugh, NumPy array enters for us. NumPy.entArray. A is read only. Import NumPy content image. NumPy.asArray.fromArray. See, that seems not to be working to me. Unless it's expecting this in a different format. Alright, let's read doc, see what it says. Remember from expecting and exporting the array interface using buffer protocol. The image is not contiguous. The 2 bytes method is called. Object with array interface. See, that's not very helpful. This doesn't give me an example. Starting from an actual array. And again, here, all you did was open up a file, then call your thing, then convert back. That's, you showed me an actual array, you know. Good, useful examples that show me the data. Alright, image, PIL, NumPy array, from array. See if I get more example. Convert a NumPy array to and display an image. NumPy array to PIL. That's more along the lines of what I want. This is going to be the same thing I just looked at, isn't it? RGB maybe is what we need. HWin3 is probably the style, whereas ours, images 0.shape, is 36464. So I need to not swap axes. Gosh, that's not the thing I need to do. Transpose. Yes. So images 0.transpose, and I want what's in 1 to go here, what's in 2 to go here, and what's in 0 to go there. There we go. And then if I say image.fromArray, that's what happens. And if I say, one of these days, NumPy.array of this, kind of dtype equals numpy.uint8. Hey, there you go. I.imshow? Is that a thing I can do? I think it's I.im. Imaging core, whatever. Image.imshow. Plot.image_show. Does this work? That does work. Okay, good. So that's a 64 by 64 image. There's some line. There's a bridge. Imagine if you really needed glasses, but you weren't wearing them. That's what our autonomous car is going to be doing. Okay, so now we've at least established how to draw images here. So, so I want to say, here we go. Open this up. There we go. I don't need to do this for everything. Lines of -1, of 0. So the last thing in the first entry, right? The last set of data points, but the first entry in there. Fill is... what is fill? What is fill? What does it mean to be fill? Let's draw. No docstring. That's great. Draw.line. Any help? Fill equals none. Let's stick with the red for now then. And see if we can do that. Oh boy. Dismiss. Ugh, that's terrible. Close. I would actually prefer plot.im show of image. See if that there we go. Okay. Now our line is starting up here. This is 0, 0, I guess. 0, 32. And it's coming down the opposite way. So I need to switch which way I'm drawing things. Right, because I need to start here and be pointed in the appropriate direction. That's so fuzzy. I would have expected a nice crisp line there. Okay. I guess it's the image show business. Weird. Very weird. Okay. So I need to futz with how I generate these lines. And then we'll call it good for today. So, okay. So I think our x status is correct. 0 is to the left, and whatever's to the right. It's just our y's that's messed up. So our height is going to be 12 in that case. 16, excuse me, 16. One of these days, man. And instead of 32, 0, 32, 63 to those locations. Right? Yes. Okay, let's recreate our image. Let's try. Interpolation setting with image show. Ah, that's I didn't know about that. That's not going to 12 though. Let me close this. Why are you not going to 12? You're starting here. Height clearly. Oh, I didn't redefine the function. That's why. Whoop. There we go. That would make a lot of sense. So I gotta re-get my lines too. Interpolation equals nearest. Ah. Where does it say that? Oh, interpolation. Hey, cool. String optional default done. Cool. Set of values are none. Neat. Didn't know that. Recreate that image. Do this, do that, do this other thing. There we go. So, just to suggest, this model is saying, hey, go slightly to the left. And you know what? In this case, that actually doesn't look crazy. We're looking at the right side of the road. It's going a little left. Not super right, not super left, not totally straight. It's listing a little left. Actually, maybe down the road you probably want to turn right, but maybe at this point, going a little left is okay. On the other hand, you might hit this barrier right here. So that could be trouble. Alright, but we have a steering model that does something. We could sit around and we could train it for a long time and really try to figure out what it's doing and hope it's doing the right thing. If we take a look at how it's doing again, we're going to see that it's not doing very well. It's doing some strange things, but generally, like, oh, it knows, oh yeah, I just need to get close to this. Close to 0.5 is fine. That's where the model is at right now, close to 0.5. So that's not crazy. It's not going to take any wild adventures, it looks like. Its maximum value isn't too far out there. So that's a plus. What about the variety of values? What are all the values? Total rave. Oh, man. Oh, I got to remake my predictions. Right. I didn't even remake my predictions. Oh, my gosh. I was using old predictions. This may change everything. The model may actually be decent. I didn't even see what the final loss was. Do I even have that here? It looks like I don't. That's fine. All right, we'll give it just a minute here to make all these predictions, and we'll look at those again. We'll make our final line drawing, and we'll see how that goes. And thanks to Connor in the audience for the tip about fiddling with the interpolation in image show. I think I might fiddle with that right now. Interpolation. I think Lanxos is an option. We'll try that. I know bilinear is an option, and I can spell bilinear. So we'll do that. Or nearest, he says. Nearest. Nearest. Oh, what did I do? What did I do? I might have made a poorly named file. We'll find out. Ever so briefly, it looked like I had a file named slash here. Thankfully, it wasn't the kind of slash that would have me removing my entire root directory. Bad ways to destroy your computer. Okay, almost there, almost there. We've gone through like 9 of these, we've got 2 more. Takes a second each, but it takes time just to open the dang file and do this other jazz. That's why I like the training for the several iterations. Okay. Here we go. So we got all preds again. Do that. That's all good. Alright. Ah, much better. I don't know what happened here. That's weird. Why is it drawing that line? Is it drawing 2 lines? That is a mystery to me. I am misusing draw. Okay. But yes, this is clearly, it's no longer a fuzzy image, now it's a properly pixelated image. And you can see, oh yeah, it's suggesting go a little bit to the left. Alright, well that is what it is. How's the, maybe I did do all new predictions. Oh no, this is actually, look at this. This isn't crazy. Check it out. This value, way down here, prediction, way down there. Make that a little easier for you guys to see. Do O's. Looky, looky. Big values down here, got a couple of big values down here, a couple down here, a couple up here. This model is starting to do something. And you notice it's tightened up here. And no longer is it just all over the place. It's actually starting to follow this curve a little bit. And it says, all right, most of the time we're going straight. But occasionally, you need to come out. Look at this. That's like spot on. I would be super happy with this. I'd be super happy with this. This model is starting to do things. It might even be actually working. Certainly needs a lot more training. There's things it's missing. Here's a hard right that we missed. Here's some hard rights that we didn't get hard right enough. That we didn't get right hard enough, you know. But the model's starting to do something, and it's starting to look decent. And that's crazy. That blows my mind, in a way. Yeah, I'm not sure what's going on with our drawing, but that's a problem for another day. Okay, so I think that's all we're gonna have for today. We did some good stuff. We made just a simple steering model from our old neural network, predicting some sane values using our very stripped down image of what our car gets to look at. And we predicted some values that actually start to make sense. And we started to work on our visualization. I should make like an animated GIF of this as it's driving down the road. That's a problem for the future. I'll work on that when I get there, and I'll sort out why there's this little tail here. I don't think, it's possible there's a little sign that's exactly red here, but I don't think that's the case in the image. All right, so thanks everyone for coming out again. We will continue our analysis of this self-driving car model next week. And don't forget to stay safe in the data mines.